In this week's Excel tutorial, we're going to take a look at how we make confidence intervals in Excel when we know the standard deviation and when we don't know the standard deviation. So in this first example, I have 15 scores over in the left column, and we're going to find a 94% confidence interval for the mean, assuming we know the standard deviation of the entire population is 13. Well, first we need a point estimate of what the mean is based on our sample. So to do that, we'll hit equals, average, select the values, and we end up with this 75.46 as our estimate for the actual mean for the population. Now, something to think about: when we have a 94% confidence interval, that means we've got the remaining 6%, because 100% minus 94 is 6%. The remaining 6% has to be split between the two other sides. Well, since it's split evenly, that means we've got 3% on one side and 3% on the other side. So when we want to find our z sub c value, what we actually want is we want to get a total area of 97% to the left of that cutting point. So that's what we're going to look for. 3 plus 94, 97% for the confidence. So we'll hit equals norm.s, because it's standardized, .inv for inverse. Then we just have to put in that cumulative probability of 97%, 0.97, and it will tell us the z sub c of 1.88 that we need to use for this confidence interval. Now we're ready to calculate the error. The error we know is equal to the z value we just found, I'll select that, times the standard deviation, which we were told was 13, divided by the square root of the sample size. On Excel, to do square root, we type SQRT and open a parentheses. There are 15 values, and we close the parentheses, and we find the error for this problem is 6.31. Now we're ready to find the low and high values on our interval. I like to have Excel do all the work, so I'm going to hit equals. We'll select the mean, and we need to subtract off the error, select the error, and hit enter. This is the low value for our confidence interval. Similarly, we will hit equals, select the mean, plus the error, and we get the high value for our confidence interval. So really, we have a confidence interval of 69.2 to 81.8. We're 94% confident that the actual mean falls between these two values based on our sample of 15. Now, the process is very similar if we don't know the standard deviation of the population. And in fact, this is more common in real life. More common in real life, we're going to have to estimate the standard deviation by using the sample that we found. Remember, when we estimate the standard deviation, that means we need to use the t-distribution. Slight difference, but very similar. First, we need the mean, which is equals average. Open a parentheses, select the numbers, and hit enter. Same mean we had before. Now for the standard deviation, we'll hit equals STDEV, and open a parentheses, and select my values and hit enter. We're going to use 16.3 as our estimate for the standard deviation. Now again, just like before, we've got 94% of the data in the middle. There's 6% of the data to be split between the two sides, so there's going to be 3% on each side, which means when we try to find our critical t-value, cumulative to the left, we've got 97% we're going for. 3 plus 94. So we'll hit equals. This time we're going to do the t for t-distribution, .inv for inverse, and the probability is 0.97, comma, and then we type in the degrees of freedom, which is 1 less than our sample size. There's 15 data values, so the degrees of freedom is 14. And now we've got our t sub c of 2.04. Now we're ready to calculate the error. Very similar to last time, equals the t-value times the estimate for the standard deviation divided by the square root of the sample size, which is 15, closing parentheses around the 15, and we hit enter and we find an error of about 8.61. We can now calculate the low and high values of our 94% confidence interval. For the low value, equals, we'll select the mean and subtract the error, enter. For the high value, equals, we'll start with the mean and we'll add the error and hit enter. So now we have a confidence interval of 66.9 to 84.1. We are 94% confident the actual mean falls within this range. Again, this time we had to use the t-value instead of the z-value because we did not know the standard deviation and the sample size was smaller than 30. On your homework assignment, the thing you'll do most often in Excel is find that t-value or the z-value using the inverse function like we did in these problems, and you might want to do some of the other things that I just showed you as well. Hopefully that was helpful for your homework. Good luck to you, and let me know if you have any questions.